Homework 69, Mr. Gazda here. Here we go. You definitely need a reference table. So here we go. First one. What is the name of the instrument to the right? That is this thing right here. Now, the idea is that you read all this. You see that. You read all of this. This is the instrument right here. Okay. You may or may not have seen it in class yet. Okay. But you go like this and you get, right, you do this with it. The key thing is that this has to be wet. And then the evaporation will cause it to change temperature, and this will be the dry bulb regular air temperature. And they're going to be different depending on the amount of moisture in the air and evaporation. But at the very least, the name of this is right in here, sling psychrometer, so it should be C, sling psychrometer, also called just a psychrometer. The swinging part makes it a sling psychrometer. It is not used to find these things. It is not used to find atmospheric pressure, because it is used to find relative humidity, how full the air is with water vapor as a percent, and the dew point temperature, which we're going to do. Here we go. So, if using this instrument you get a dry bulb temperature of 18 and a wet bulb of 14, what is the relative humidity? So, you want to go to the page of the reference table, which is going to be page 12. And on page 12, you want to make sure you are in the correct chart, because there's two charts here. The top one is dew point, and the bottom one's relative humidity. This is percent. This is the temperature. Make sure you're in the right one. Relative humidity, I should be down here. The key thing here is, if dry bulb is 18 and wet bulb is 14, what is the difference? 18 minus 14 is going to be 4 degrees C, and that's the difference. That is key. Differences 4. Too many kids will come here and look for 14 down here. That's not right. This is the difference between the wet bulb and dry bulb temperatures. That is key. That is where everyone messes up. Therefore, my dry bulb here is 18, and the difference is 4. So I go like this. I go 18, okay? And then I go over to where 4, and sometimes you can get messed up. You really got to kind of, 4 is here, and 18 is here, okay? And it's 64. And the answer is 64%. The air is 64% full of water vapor, of how much water vapor it can hold. That's what that means, for like kind of percentage full. When it's totally full, it's 100% relative humidity, and then at that point you have condensation. 3. This example, dry bulb temperature is 12, wet bulb temperature is 9. Here we go, 12 minus 9, the difference here, and if you need to write it on the side, definitely do. The difference of 12 minus 9 is 3 degrees C. So I'm going to be looking in the row for 12 degrees C, and the difference of 3. Though at this time they're asking for dew point temperature. So I got to go to the other chart, which is up here. Always check. This is going to be a temperature. 12 is my dry bulb, difference is 3. Dry bulb of 12, and then a difference of 3 is right here, so 6 degrees C. Okay, 6 degrees Celsius. That means the air temperature, if it's currently 12, it would have to drop down to 6 degrees Celsius for it to be 100% full of water vapor, and that's where you're going to get condensation. Which city below has the highest chance of rain, Chicago or Boston? And the key thing to look at is how close the air temperature and dew point is. Here, they're off by 2 degrees Fahrenheit, and here they're off by 13 degrees Fahrenheit. So this means the air has more moisture in it. It would only need to cool down 2 degrees, which is very doable, for the air to be 100% saturated, which would be clouds or fog, and this would have to go down 13, so the air is drier here. Therefore, the answer is Chicago. So it's less important that you get it right. I mean, there's only 2. Some people could just randomly guess and get it right. It's understanding the closest to the dew point and air temperature. The closer it is, the more moisture in the air, the closer it is to raining or getting clouds. 5, important fact, cold air can hold less water vapor than warm air. Now this is just really important part of this. I really hammer this over and over. The warmer the air is, the more capacity it can to hold water vapor, and that's what causes the dew point to occur. Therefore, this graph shows air temperature low to high and how much water vapor it can hold. It should look like this. The hotter the temperatures, the more water vapor can hold. That is important. 6. Dry bulb is 22, wet bulb is 15. The difference here is, just subtract them. 7 degrees with my dry bulb, 22. I'm looking for dew point. Here we go. What are we doing? Dry bulb of 22 with a difference of 7. 22. So that should be 10 degrees Celsius. It would have to go from 22 degrees to 10 degrees Celsius for dew to form or clouds to form. Okay, so that's a pretty big drop. especially in Celsius. This one's asking for relative humidity, 28 to 22. The difference here, difference is 6 degrees C. Okay, so with the dry bulb of 28, there are too many people. Very often they use the wrong row, but you just got to stay on top of this thing. Stay on top of this stuff. 28 and 6 is the column I'm going at 6. So you always got to double check. 6 and 28, 59%. The air is 59% full of water vapor. 59%. Okay, hope this is making some sense. Now, please match up the last 2 digits of your locker number with the 2 letters that are next to it, and then write them on the front of your paper in a circle right next to your name. Thank you. Let's go on to the back. Here we go. Let's go on to the back. So what we have here is on what causes the wet bulb temperature and dry bulb temperatures to be different. So for instance, here, they're not wet. These are the same temperatures. You may not be able to see it based on the video here, but the same temperatures. Once I get it wet and swing it around, what causes the wet bulb will always be cooler. Okay, and the reason is because evaporation from the wet bulb requires heat, and it takes heat away from the thermometer. Okay, so evaporation off the wet bulb will take heat away from that thermometer. The more evaporation, the more heat's taken away, the lower the temperature. That is key. The simplistic answer and kind of the wrong answer is like, oh, well, water makes things cold. That's not true. So hopefully it's something like that in there. That is a very tough question for students. 9, as temperature decreases, the amount of water vapor air can hold, does it decrease, increase, or stay the same? So as it gets colder, the amount of water vapor that same air can hold goes down. It can hold less. Okay? Station models, decoding air pressure. So this is the example. If it's written on a station model like this, right, that's an abbreviation for air pressure. The air pressure is not 952. That air pressure is not 12. Okay? What you need to do is remember something about 500. Above 500, below 500, add a 9 or 10. If you remember that much, you're in good shape because the reference table is going to help you. Okay? This right here, it is 196. That is below 500, and it tells you what the actual number is. So 196, they added a 10 in front. Okay? Therefore, below 500, you add a 10. And no, the flip side must be, well, above 500, you must add a 9. In addition, just a little this is kind of a cheater thing. Your number should be one of these. This is sort of the reasonable range of air pressure. So if yours is not here, it's a good check. It is a bit cheater, but that's fine. Use it. So for instance, this is above 500. You add a 9 decimal millibars. Use that. So this one here, I would always recommend you're going to write the units on there too. So 987. Write that first. Okay. Right, millibars, and then what you want to do is that is above 500, use this, because below 500 they add a 10, above 500 you add a 9, okay, do that, and then a decimal place between the last two, 998.7 millibars. This gets a lot of kids because they just don't really thoroughly ever really learn it. This too, write this first, 163, right in the units will be millibars. This is below 500. Use this as a guide. It's below 500. They add a 10. Do that same thing here. You add a 10. And then a decimal between the last two numbers, 1016.3. And if you were to check, that would be within this range. A good way to check, good way to make sure you get it right. This one, 048. Must write the 0. Very important, must write the 0. It's going to be millibars. And then this is below 500. You add a 10. And then you put a decimal in there, 1004.8 millibars. Okay, this too, definitely do by 995. If you don't write it first, kids have usually miss a 9 or miss a 0 here. Trust me on this one. Okay, that is above 500. So again, using this guide on the reference table, use that. Again, below 500, the real number they added a 10. So the flip side, above 500, you add a 9. And you do this and put a decimal here, 999.5 millibars. That is key. So, this one here, using the circle below, draw a station model for the atmospheric conditions at Kinderhook. Okay, so this is the conditions at Kinderhook right here. I give them to you. Okay, some people I've seen can be confused with that. This you're going to write onto here. Okay, this is our station model. Use this as a guide. So this is what a station model will look like. This tells you what things are. Yours should look like this, no units on it, and no decimals except for this. Okay, so That is key. So for instance, air temperature, look where air temperature is. Air temperature in Fahrenheit is this number here. It's this number there. You write it right there. No units. No units on this. So 46. The dew point temperature, if you look around here, dew point is right there. So you write it in that general spot. And in this case, the dew point is 37. Cloud cover 100%. So this circle, how much filled in it, how filled in it is, tells you the cloud cover. In this case, it's 3/4 filled in, 75% cloud cover. So we're going to fill it in for this 100% cloud cover. You're going to fill it in completely. Okay, and we just do, usually it's like 0%, 25, 50, 75, or 100. You know, there's no 31% cloud cover. It just doesn't work that way. Wind direction from the northwest. This drives people crazy. Look at this direction here. It's all on here. Wind direction is this, from the southwest, so it blows this way, from here towards the circle. Okay, know that. Use this as a guide. This will help you. This means from the southwest, it blows this way. So from the northwest is going to go from here towards that way. So it should look like this. Okay, you put it on like this. Okay, it means that it's blowing that way. And then wind speed 15 knots. These feathers here, okay, one feather is 10 knots, whole feather, and the half feather is 5. So this shows 15 knots right here. You're going to do the same thing. Make sure one is bigger and one is smaller. It could be either way, up or down. It doesn't matter. Okay, that's a full one. That's a half one. That shows 15. It could go the other way. That does not matter. And air pressure, the reverse of this. To do it, last 3 digits only, no units, and no decimal. Therefore, that's going to be just these numbers there, 1, 6, 2, written like that. No units, no decimals. There you go. That is that information there. The rest of it, they don't give us, so we only write that. Okay? Hope this helps. This stuff is tricky for kids, so stay on top of this for sure. I'm Mr. Gazda. We are at Gazdoni Productions, and I approve this message.